In my two previous videos, I had the pleasure to show how to create hand presence with physics interaction. And as you guys seem to really like this physics-based VR tutorial, I decided to make this extra episode on how to create the same physics interaction, but for hand tracking on the Oculus Quest. As always, you will be able to find the source code of this project down in the description of this exclusive Patreon tutorial. But now I hope that you guys are ready, so let's get started with the tutorial. Okay, so for this project, I'm using a Unity version above 2019.4. Mine is 2020.3 with the universal rendering pipeline. Now, as you can see, I've already downloaded the Oculus integration package. And if we go in the project settings, I've already made the VR setup using the XR plugin management for Oculus on both desktop and Android. So as you guys can see, I have the same starting environment as for the other hand physics tutorial I made, with here a ground, a black cube for the table, and this red cube sitting next to a red sphere that have both a rigid body. Now we are ready to get started, so the first thing I'm going to do is set up the hand tracking for the Oculus, or should I call it the Meta Quest. We can first remove the main camera. Then I will search in the project for the OVR camera rig and drag it in the hierarchy. Make sure here that its position is set at 0, 0, 0. Now we want to take into account the height of the player, so I'm going to change the tracking origin type from high level to floor level. Perfect. Now that we got that ready, if we want to see our hands with hand tracking, we can search in the project window to OVR hand prefab. We can drag them under the left hand anchor. I'm going to rename it OVR hand left. Now, as you can see, the material of this hand is pink because I'm using the URP and this shader is not compatible with it. So if you have the same issue, we can change the shader to something else like the universal rendering pipeline lit, and we can even change its color to something we want. There you go. So this was for the left hand. Now we can do the same but for the right hand. So I will drag the OVR hand prefab in the scene under this time the right hand anchor. We can rename it OVR hand right. But this time, as you can see, we need to change the hand type to right hand on all of the components on this prefab. So make sure to do it for the OVR head component, the OVR skeleton, and the OVR mesh. Perfect. Now everything is ready to test our game. We can either build and export it directly to the Oculus Quest, but in my case I'm using the Oculus link, which will allow me to test the application directly here in Unity. So let's do this. Okay, and here is the result. Hand tracking is working really well and I can move my little fingers. But for now, with this setup, if I try to interact with this cube, it doesn't work. My hand does not collide. And so let's see how we can fix this. Now in the previous video, we had to simply add collider to each bone of the hand mesh to be able to interact with the cube, but with the hand tracking, it's even easier. We can select both our hand and here, click on Enable Physics Capsule in the OVR skeleton. And now if we click on play, I can now interact physically with the cube, but with this Enable Physics, this also adds capsule collider to each bone as well as a kinematic rigid body. Now, if you have already watched my previous tutorial on how to make physics hand in VR, you might know the issue that we will have with this setup. Because the rigid body is kinematic, our hands collide with the cube but pass through the table. Even more, the interaction does not feel very precise. Now, in the previous video, we were able to solve this issue by setting the rigid body of the hand to non-kinematic and make our own component that would move the rigid body to the position of our controller. But this time, with hand tracking, it gets a bit trickier. More than the position of our controller, this time we need to make each bone physically move to the target position of the non-physic bone. But that's not it. Because our finger can only move in a certain direction, we need to add a physics joint to all our physics fingers to restrict their movement and make them behave realistically. Now I guess that you start to understand that this would take us a lot of time to set up and might not even be possible to make in one single video. So we need to be smarter than this and find another solution. And the solution we are going to use is HPTK. But what is HPTK, the Hand Physics Toolkit? Well, as the name suggests, HPTK is an open source toolkit to help you create hand physics interaction in Unity and made by George Gonzalez. And by the way, sorry if I pronounce your name wrong. It comes with a pre-configured hand, is platform independent, so you can even use it for other devices supporting hand tracking like HoloLens, and it has some pretty additional features like gesture detection, for example. But now for the remaining of this tutorial, let's focus on learning how to set up the Hand Physics Toolkit for a project to have some really cool hand tracking physics. Okay, so you will be able to find the project on this GitHub page that I will leave in the description below. Now, as you might already know, we can either add the GitHub by copying here the Git URL here and going back to Unity. Now, next, open the package manager with Window, Package Manager, and here at the top, click on the plus button and add package from Git. And now this is where we can pass the GitHub link to add this project. But in my case, I've previously downloaded it here in my folder. So I'm simply going to drag it in my project. And once it's imported, we can start the setup. I want to improve the physics of our game using the Unity physics. Now, I've talked about these settings in the previous video, but if you don't remember, we can go to Edit, Project Settings, Physics, and we can do the following setup. Default solver iteration to 25, solver velocity to 15, we can enable the alternative force, next set the friction type to one directional, and the solver type to temporal goes. But finally, we can even go to the time settings and change the fixed time step to 0.01. Perfect. Now that the settings are done, I'm going to select both the hands that we added previously. We can now uncheck the enable capsule physics setting, and then I'm going to disable the OVR mesh renderer as we are going to replace these hands with the hands from HPTK. So next, to set up HPTK for the Oculus, we need to download an extra package that we can find by going to HPTK, Samples, Integration, Packages, and here double click on Oculus. Now this will import a Unity package with some pre-configured physical hand for Oculus. We can click on Import. Perfect. Okay, so the first prefab that we need is the main HPTK prefab. So let's search for it in our project windows. We can drag it in our scene. And now, as you can see, this prefab contains the main HPTK component, which need here the track camera and the tracking space. So we can drag the center area ensure in the main camera and the tracking space game object in the tracking space variable of this script. And there you go. Then, as you can see, we need to have below data providers that HPTK will read for the physics. This is where you could use HoloLens or other any device input, but as we are using the Oculus Quest hand tracking, we can search for OVR input switcher left and right in the project windows. So these are the two prefab that we imported before with the Oculus package of HPTK, and we can drag them both as child of the HPTK prefab. Perfect. Now what we can do is drag the OVR input switcher left in the left editor IDP and the left build IDP. Then do the same, but this time for the OVR input switcher right. Then if we go to the OVR input switcher, then OVR skeleton tracker, we can see that we need two data, the hand data and the bone data that we can find in the OVR hand left under the OVR camera rig. So I'm simply going to drag here for the OVR skeleton tracker left, the OVR hand left on both of these two variables. And now, as you guessed it, we can do the same, but this time for the right of VR input switcher. Okay, perfect. So at this stage, we have set up the information that HPTK needs to make physics, but we are missing something important, the hands themselves. So for this, we can search default avatar, and as you can see, we have two choices. An avatar if you are using the universal rendering pipeline, and another for the standard pipeline. But in my case, as I'm using URP, I'm going to select the first one and drag it in my scene. And ta-da! Now, as you can see, this shows two pairs of hands in our scene. The one on top are the master hands, which does not obey to the physics, and the one on the bottom are what they call the slave hand, which will try to follow at best the master hand. Now, to show you this, we can go to the representation, and there under the hand left, for example, you can have a look at these two types of hands. And if we compare even their children, so for example, the left wrist, the master has the representation model component, which will be controlled by the wrist bone, and the other, on the slave, use the pupper representation model, which as you can see use physics. And this is what made the difference between these two hands that are listening to the input of HPTK that we set up before. And just like that, our setup is completed. We should be able to test our game and see both sets of our hands. So let's click on play to try this. And there it is, guys. Now, as you can see, we are able to see our hands, and if we try to collide with the cube, it works. And we can even push it around. That's really cool. But now for the big test, if I try to go through the table, it also works. Using this package, we can see now that the hands collide realistically on the table. But what I like the most is it's now possible to grab easily object with this setup. So for example, as you can see, I can grab super easily the ball with one hand or the cube using both hands, and everything is handled with Unity Physics. And it goes beyond that, because I can even have two objects with different mass, like this one on the left and this one on the right, and when I try to grab them, the weight of these objects is taken into account. That's awesome. Now, unfortunately, this is the end of this tutorial, and what an interesting setup it is, right? It feels like a world of possibility just opened with this awesome HPTK package, so thanks again to its creator, George Gonzalez. Now, there is definitely more to unveil with this package, so if you guys are interested to know more about it, let me know in the comment section below. I also encourage you to have a read at the documentation, where you will find more information about it as well. But now, thank you for watching till the end and supporting my work here on Patreon. You guys are the best. See you soon and bye bye.